people behind you or around you, but actually asking questions and being, applying yourself to the lesson. So today we are going to graph linear inequalities in two variables. A one variable inequality, if you remember back to the very first unit when you walked in this door.
Like last semester?
Like last semester, beginning of your high school career, was something like x is greater than 1. And we are on a number line because it was a single variable. We used an open circle because it wasn't or equal to, and we shaded it to the right. Do you remember that?
I don't like these.
Do you guys remember those, though?
Yeah, I remember it.
Or if it was something like this, whereas x is less than or equal to -2. We graphed our number line. In this case, we had a filled-in circle because it was or equal to, and since it was less than, we shaded it to the left. Because those numbers made the statement true. If I plug in any number on this side, 2 is greater than 1. True. 100 is greater than 1. True. Do you see that those numbers all make that true?
Yes.
In this case, if we're looking here, -3 is less than or equal to -2. -3 is less than -2, so that's true. -1000 is less than or equal to -2. That's true. All the numbers to the left make that statement true, and that's why we shade it that way. Today we are going to expand our lesson, and we're going to look at this in when we have both an x and a y. When you have both an x and a y, you're no longer on a number line, you're on a coordinate plane. You have your ordered pairs. So that's what we're going to be looking at next today. Okay, so the solution of an inequality in two variables is an ordered pair x, y. Do you need me to go back?
No, I
just wanted to make sure. That makes the inequality true. So tell whether each of these ordered pairs is a solution of -x plus 2y is less than 8. So what we're just going to do is we're going to use this as our x and our y, and we're going to substitute into -x plus 2y is less than 8. If I do that, I have -0 plus 2 times 0 is less than 8. Well, 0 can't be negative, so that was kind of a silly statement, but 0 is less than 8. Is that true or false?
That is true. True. Oh, sorry. I'll make this fun.
So 0, 0 is a solution. Again, we have an x and a y, and we're going to substitute those in to our variables in the inequality given to us. Again, -0 is kind of funny, but I'm putting that negative there just so you guys get used to it being there if there was an actual number. That is not 0, I should say, because 0 is an actual number. So 8 is less than 8. Is 8 less than 8?
No.
No, 8 is 8. So this is false. So 0, 4 is not a solution. So I have -1 plus 2 times -3 is less than 8. So I have -1 minus 6 is less than 8. Is -7 less than 8? So this is true, so this is a solution. So we are going to use this concept when it comes to the shading. Because remember, when I did those examples on that front slide, they were shading to the left or to the right. Well, when we graph a line on a coordinate plane, we're going to have to shade above or below the line. So we're going to choose a test point, and we're going to do the same concept and substitute these numbers in and see if it's true or false. If it's true, that means it is a solution, so you should shade that side. If it's false, that means you shouldn't be shading that side because that's not a solution that works, and you have to look at the other side. Okay? So we're going to look at that test point thing. I'm going to show you another way of how to graph it tomorrow as well, like without the test points, but I want to get you guys started that way today. So steps to graphing a linear inequality. First, graph the inequality. Since it is an inequality, and if you think back to what I did on that very first slide, you see how we had open or closed circles? We need to determine if it's not included or included. Remember, if there's no line underneath, it's not included. In this case, we used an open circle. If there is a line underneath, that means it is included. So to show that on a graph, you're going to use dashed lines versus solid lines. So if there's no line underneath, it's not included, and you use a dashed line versus the open circle. So this is like our open circle. If there is a line underneath, that means it is included. You use a solid line to mean the line is a part of the solution. So dashed line means any number along that line is not part of the solution set. A solid line means every point along that line is part of the solution set. So that's how we denote that in graphing versus on a coordinate plane versus on a numbered line. Then you're going to use a test point not on the line. If the point is a solution, meaning it is true, you will shade on the side where that point lies. If it is not a solution, meaning it makes the statement false, you're going to shade on the other side of the line, the opposite side of the line, because the other side must be true, because you're either true or false. There's no in between, and you want to shade on the true side. Okay, so let's graph this. So y is greater than or equal to 3x plus 1. So we're going to graph it the same way as normal, but instead you guys are going to have some shading going on and some dash versus solid. So I'm going to just put one ruler down between the two of you sitting next to each other because I don't have that many and I keep forgetting to order some whenever I'm on Amazon, which I order from all the time, so I don't know why I can't just think of it. I know I should. I literally just ordered stuff this weekend, so it would have been real easy to do so.
Oh my lady. What?
Okay, so where do we start, Blaine, when we go to graph this?
I'm ready.
Guys, no one should be talking. I don't know why talking is happening. Yeah, but how do we graph that inequality? Where do we start? No. It's a line. It's the same way we graph y equals mx plus b. Where do you start with y equals mx plus b?
Oh. Go to 1.
Good. Then what?
And then 3 over 1.
Which way over?
Right.
Okay, so the first thing we're going to do is just plot some points. Now, I'm not going to connect them yet because I have to ask myself a question. Should my line be dashed or solid, and why? So, Jack, should my line be dashed or solid, and why? So, this line underneath means or equal to, which means that it's included. So, which line means included? Sorry. The dashed line is like an open circle, and we want it to be like a closed circle. So, for an or equal to, we need a solid line to mean that those points are on the line are true too. So we need a solid line when we have the or equal to. So connect your points with a solid line.
So if it's or equal to line, if it's not or equal to.
If it doesn't have that line underneath, then it's a dash line. Okay, so that's step number 1, is just graphing it. The next step is to choose a test point. So what test point would you guys like to try to use? And it cannot be on the line. So give me a test point. Okay, go ahead, Connor.
1, 1.
So Connor has chosen 1, 1. So we're using that as our test point, and we're going to go back to our original, and we're going to see if that's true. So is 1 greater than or equal to 3 times 1 plus 1? So is 1 greater than or equal to 4?
God, you know.
Is this true or false? Okay, so if this side is false, so we know this side is false, then that means that the other side must be true. And which side do we want to shade on? The side that is true, because we want our solutions to be in that. So I'm just going to use, I'm not going to shade that dark, I'm just going to use lines to get used to for tomorrow. So I'm just going to use lines, and that means I'm shading that. So we want to shade on the true side. So since we found out that this side is the false side, there's two sides. One side's true, one side's false. So we want to shade on the true side. Since this is false, we shade on the other one. Yeah.
So, let's say I did the point -2, 2, then...
That should come out as true. So if you substitute in -2, 2, 3 times -2 is -6.
Yeah.
Plus 1 is -5.
Yeah.
Is 2 greater than or equal to -5?
Yes.
Yeah, so that's why you're shading them. Okay. So is 0, 0 a solution based on our graph? Kaylee, you're shaking your head no. Why not? Okay, so you could substitute it in. Is 0 greater than 1? No. If you substitute it in. If you're looking at the graph, why is 0, 0 not a solution? Tanari? It's on the false side, right? It's on the false side of the line. It's not on the true side. So it's not on the side with the shading. So, no, it is not on the side with shading. You can plug it in. You can also say, well, 0 is greater than or equal to 1 is not true. That's another way to look at it. Okay, questions there so far? Yes?
So wait, the or equal is like the solid line, and then like the other one is like that.
Jordan?
I'm lost.
Where are you off? Did you get the line being graphed?
Yeah.
Do you understand why it's solid? That's the first
Because
thing.
of the...
Yes. Okay.
Okay.
Are you confused about the test point?
No, I'm confused about how you figured out which side to shade.
So I just told somebody to choose a point. So Connor happened to choose 1, 1. He could have chosen something on this side. So he happened to choose 1, 1. So we substituted in 1, 1 to this, and it came out as false. So that means that this side of the line is false. So if this side is false, then that makes side, right, because that's where the point is, exactly. So that makes this side true, and we want to shade the side that's true because it makes this inequality true.
Okay.
Does that make sense now?
Yep.
Okay.
Thank you.
Okay. Are you still talking? Why? Okay, Justin Powers, get this into slope-intercept form for me. You're too distracted. What did you say to do?
-4y plus
So, how would we want to get y alone? So what do we do to get y alone? What? Subtract what? No, the y is what we're trying to get alone. Okay, x is already positive, so we need to. What do you still have to do, Justin? To get y alone. And we have to remember with inequalities, if you multiply or divide by a negative, you must do what with the inequality?
Flip it.
Are we multiplying or dividing by a negative? No, it's a positive, so we're good there. Huh? Colin, how would I graph that?
Alright. Oh shoot. So let's see. Put together, okay. So what you're gonna do is you're gonna start at -2, right? Yeah, okay. And then you're just gonna go down 1 and then to the right, or not to the, yeah, to the right 1. I do maths.
Okay,
Got scared for a second.
Mike,
It was just making me go.
would our line be dashed or solid?
Solid. Dash. Because it's, there's not a line under it.
Right, it's not equal to, so it would be dashed. So your line needs to be dashed. If you graph your line and then just erase points off of it, that works too. That tends to be what I do. So your line should be dashed. I recognize that my line is not dashed yet. Just 1 second here. So, questions? Stop for a second, guys. Side conversations don't need to be happening. Do we understand why this line is dashed?
Yes.
Are we sure?
Yes.
Okay. So now we're going to choose a test point. It doesn't matter where that test point is. You just have to choose one. So, Lexi, what do you want my test point to be this time?
1, 2.
So the point 1, 2. So I'm going to test point the point 1, 2 in my original equation. I always go back to my original. Is 9 less than negative 8? No, so this is false. So that means right here is false, and down here is true. What side do we want to shade on?
True.
True, so we shade the side that has the true. The reason that that's the side that's false, because this was a good question Jordan had, is the point is right here. So that's why I marked this side false, because it's based off of that. If that had been true and this is where my point was, I would have marked this part as true. Okay? So that was a good question she had earlier. Is 0, negative 2 a solution?
Yes.
Okay, it's on the line. Is our line dashed or solid?
Dash.
Does dash means included or not included? So is that a solution?
No.
No. It is on the line, but the line is not part of our solution. I'm going to say no. Sorry.
Ah! Thought I had it right. I was testing.
All right, next one. Oh, it's an x is greater than negative 4. Who remembers what x means?
X is a number.
It's vertical.
It doesn't get vertical.
It needs to cut the x-axis, so it's a vertical line.
I'm not wrong. You're not.
Now, before we graph this beautiful vertical line, Riley, is my line going to be dashed or solid?
It's gonna be dashed. Good job, Richard.
Good job.
I didn't recall. Besides my own. Greg. And I don't.
On Greg.
What? Yeah, okay. Remember that guy who came in saying that? Yeah, I thought you said that.
Who hurt you?
No, it's my stepdad. Yeah. Excuse me. That was you. See?
That's my bad.
Your line is dashed. Come on, guys. All right. We need to choose a test point. We need to choose a test point. Jayla, what do you want my test point to be? Woo-hoo. So So we only have an x to substitute in for. Is 3 greater than negative 4? So this time our test point happens to lie on our true side, which means that this side here is false. Do we shade on the true side or the false side?
True side, always, never not.
Now, last question on this one here, Brian. Sorry. Brian?
Did you break it?
I don't know. Is 2 a solution? Why is it a solution, Brian?
Because it is on the side that it's shaded.
Yes, it is. The point is on the side that is shaded.
Is this what we're basically doing for us?
We'll be doing systems tomorrow with this. Two of them on a graph.
Jimmy Neutron.
And then you shade where they overlap.
Probably something other than this.
Welcome to the shadow realm, Jimbo.
Okay. Do I need to separate you guys even more? I don't understand.
This is separate. Put Colin right there.
Put them anywhere they'll
I might have to. It's getting to a point that it's not okay. You need to stop.
Put us in separate rooms.
Okay, what kind of line is drawn, Jordan Coward, with a Y? It is horizontal. It needs to cut the y-axis. I don't know why I put X's there. So, Y. Josh, is this one a dashed or solid line? So this is or equal to. So that means our line is solid. Please ask questions if you are confused how I'm getting these solid lines, dash lines, shading, any of that business. Tanari, what test point do you want to do this time?
3-1.
So we're testing the point 3-1. Since we only have a y in this one, we're just going to substitute in the 1. Is 1 less than or equal to 5?
Yes, ma'am.
So we always shade where our test point is true, or if our test point is true, we shade on that side. The other side, which is up here, is our false side. And we want to shade where it's true. So we shade the graph. Yep. So it asks you, is negative 5 a solution? Is negative 5 a solution? So how is this different from the last one that lied on the line? Yeah.
It's a solid line, so it's included.
Yes. So since this line is solid, it is included. That's why it's okay that this one is on the line. If this had been a dashed line, would this be a solution? No. So, yes, it is on a solid line. It is on an included line.
Bring more thought.
I care. I have a headache.
This is all bad.
You should probably take some 9 drowsy medicine.
All right. The next one, we have to put into slope-intercept form. So, Jana, what would you do first to get that into slope-intercept form? Then what, Jana? Guys, if we divide by a negative, we must.
Flip the sign.
We have to flip that inequality. It has to do with
I just wonder about math and which guy decided to make them.
Okay, so if you do this problem here, we're saying if we don't flip the inequality, we're saying x is greater than negative 3. Well, if I plug in a number like 2, negative 2 times 2 is greater than 6. Is negative 4 greater than 6? No, so that doesn't make it true, even though that's what our answer said. So that's why we flip the sign, so that makes sure that our answer stays the same. So we're saying that actually the number has to be less than negative 3. So if I do negative 2 times negative 4 is greater than 6, is 8 greater than 6? That's why. So it keeps it true. You asked why. Don't look at me like I shouldn't have answered your question.
No, like, it didn't, I get confusing.
I'm sorry. I'll find something else, another way to show you later. So we start at negative 2, and we go up 1, right 3. Okay, before I connect these points, Jack, will my line be dashed or solid? It's dashed. This is not equal, so it's dashed. Jordan, what test point do you want me to do? 1, 1. So I'm going to do a test point at 1, 1. And I always go back to my original. So my original is x minus 3y is greater than 6. So that's 1 minus 3 times 1 is greater than 6. 1 minus 3 is greater than 6. Is negative 2 greater than 6? No, so that's false, which means that this side is my false side. So this must be my true, and we always shade where it. Is negative 3, 1 a solution, Brian? Is negative 3, comma 1 a solution? No. It's not in our shaded region.
Oh, my notes. Oh, I only got 2 more, never mind.
Come on, man, John's always.
No. I know that.
Sorry.
There's, John Sullivan. No.
Okay, before we can graph this, what do we need to do? Before we can graph this,
Divide by negative.
before we can graph this, you have to divide by a negative. When you divide by a negative, what do you need to do?
Flip the sign.
Flip the sign. So, technically, we don't have this, but this is like adding 0 at the end, which means that we start at 0, and our slope is down 1, right 1. It's just equal to the opposite of what it is. That's all that's saying. So if y is 1, x is negative 1, and so on and so forth.
Yeah, I know later.
Is my line, Irish Connor, dashed or solid?
Dash. Yeah, good job, Irish. Oh, whoops. Did.
So we need a test point.
Eat lettuce.
Cassie, what test point do you want to use? You said 1, 1, right? Always make sure it's not on the line. You guys are doing a great job of that. And we always go back to the original. Is negative 1 greater than 1?
What?
No, this is false. Now, Connor, is 0, 2 a solution?
No.
Nope, 0, 2 is right here. It's not on the side that is shaded, so that is not a solution. You are right. My brain is not working. Still no, so we're good there at least. At least that half was good. All right, last one. You can spend at most $9 on mittens and hats for the winter. Mittens cost $1.50 a pair, and hats cost $3 a pair. Write and graph an inequality that represents the amount of mittens and hats you can buy, and identify and interpret two solutions. So, X is going to be the number of mittens we can buy. And Y is going to be the number of hats. So I'm going to label that on my X and Y axis here. So this is mittens. And this is hats. Just so I know X and Y here. So mittens cost $1.50. So we would say $1.50 times what variable? Plus. And we can't spend more than the $9 we have. So if we solve for Y here, we would subtract 150. And divide by 3. What is $1.50 divided by 3?
25.
Is it 0.5? Is that right? Negative 0.5?
Yeah.
So I'm gonna say negative 1/2 x because it's easier to graph that slope. 0.5 is 1/2. So if I start at 3, I go down 1 over 2. Would my line be dashed or solid? Solid. Now, can I go into the negatives with this? No, I cannot. So this is going to be my line. It's going to start and stop right there because we can't have negative mittens and hats, right? So in this case here, if we choose a test point, I'm going to choose the test point 1, 1.
Oh, yeah.
To go into the original, I have 150 plus 3 is less than or equal to 9. Is 450 less than or equal to 9?
Yes, ma'am.
So again, I'm only shading in here. So these are solutions.
This is ridiculous. So much stuff, I know how much that's cost.
So somebody give me a possible solution. Somebody give me a possible solution and we'll interpret it. Besides 1, 1, because we know that's a solution. So somebody give me another possible solution here. What? 2, 1. Is 2, 1 in our shaded region?
Yeah.
What does 2, 1 mean in context of this problem?
2 mittens, 1 half.
As a sentence, please.
You can buy 2 mittens, 1 half for $9.
Not for $9.
Oh, well, you know, less than or equal to $9.
Oh, I could bring 2.
So for less than $9. I'm not going to do a second one with you, but anything in that shaded region is a solution.
Wait,
Okay.
is that like the whole